Well, hello. Long time no see. I've been kind of putting this off because I really don't want to do it. But I guess it's finally time. I'm gonna go over paper 3 of HL, the one that they gave out this year. And you know, the reason why I don't want to do this is because it looks hard. But whatever, it's fine. I'm sure everything will be fine. So for those that don't know, this paper 3 is it's a new style. So before our new curriculum in this course, Analysis and Approaches, HL students would select an extra chapter to learn, so calculus or statistics or something, and then they would get a third paper based on their choice. And then now they're trying to do this weird thing, like it's like a guided problem to explore whatever they want you to explore. So in this question, you're going to explore the behavior and key features of cubic polynomials in this format here. So I guess we'll get started. Okay, so let's consider this one, it's plus 2. And then C is going to be some parameter. And then what we have so far is we have, when C is minus 1, it'll look like this. And then when C is equal to 0, it'll look like this. Okay. And then on separate axes, we're going to sketch and then show the y value and the coordinates of any points with 0 gradient for these two. Okay, so paper 3s, you're allowed a graphing calculator, so if they want you to graph something, then just graph it. So I'm going to use Desmos. So we're going to try out when C is 1, so we're going to have minus 3x plus 2. And then, as you can see, it looks pretty wild. You have a local maximum here, you have a local minimum here, y-intercept here, and then a second x-intercept here. So, I don't know, I guess I'll sketch it out. So it go like this. Actually, I think it was like this. So we have negative 2 and 0. 1 and 0. 0 and 2. And then here, negative 1 and 4, I think it was. Oh, hello, Serpent. I met your mom today, after school. Nice lady. Okay, not really to scale, but you get the point. So this is when C is 1. And then we're going to try C equals 2. So what this is it's like a guided exploration. So as you notice, when C is negative 1, it looks like this. And then when C is 0, so you're increasing C, it starts to flatten out. And then when C is 1, it goes beyond flattening out, and then it starts to dip like that. Like this middle part is like, first it starts like that, and then it's like turning over like that. So I'm curious, I guess, to see what happens when C equals 2. Is it going to be more extreme? And that's the point of this exploration, is to do that kind of thing. So if C is going to be 2, then it's going to be 3 times 2, which is 6. So as you can see, it becomes more extreme. Okay, so you would sketch this out, you would label everything that is of importance. And they want you to show the value of the y-intercept, so that is still 2. And then it says any points that have a 0 gradient. So that would be our local maximums and minimums. So in this case, this number and then this number. Seven, 6, 6, negative 3, 6, 6. Okay, so I think my prediction came true, and then as you can see, I'm on Desmos, so I can do this. And you could also kind of do it too on a graphic calculator. Just experiment and try out different values to see. So as you can see here, we started at -1, so it looks kind of like this. And then as we increase C, it starts to like turn and rotate around the y-intercept. And then it'll get more extreme as we keep going. And then if we go this way, eventually it would turn, yeah, so there you go. Anyways, whatever, that's easy, 6 marks. And then write down an expression for f prime of x. That's easy enough to do. So here's our original function, I think. And then we take the derivative. So you get 2x squared minus 3c. Nice. Okay, and then we move on to the second question, or the second page. So I took this with a phone, a picture of the paper with my phone. But, okay, copy. And then, hence or otherwise, we are going to find the set of values C such that the graph is going to have a point of inflection with 0 gradient. Okay, so the first one. The point of inflection means that we need a second derivative, so this is going to become 4x minus 3. And the second derivative needs to be equal to have a point of inflection, which means that x is going to be 3 over 4. And then that doesn't necessarily help us solve C. However, it does say that this point needs to have a 0 gradient. In other words, the first derivative needs to be equal to 0. So 2 times 3 over 4 squared minus 3c needs to equal to 0. And then we can solve for C. What is this going to be? So 9 over 8, 3c equals 0, so c is equal to 3 over 8. 3 over 8. So let's try that out. Let's see what happens when we have a point of inflection with a 0 gradient. You can check your answers because you have a graphing calculator. So when c is going to be, what was it? 3 over 8? I guess I didn't do this right. Because you can see the point of inflections here. This is where it changes concavity, and this is definitely not a 0 gradient. So where did I go wrong? It's only worth 1 mark. Point of inflection with 0 gradient. 1 mark. Is it right here? When c is 0? But why doesn't my way work? Did I even take the derivative correctly? Did I even write down the function correctly? Cubed minus 3cx plus 2. Oh, what the heck? This should be 3. Ah, stupid mistakes. So, yeah, bring down 3, and then bring down 2, so that's 6. Solve for this, that's 1/2. So 1/2. That's gonna be 1/2. So 1/6. But that's still not right. Okay, this is f. This is f prime, right? Oh, whoopsies. Yeah. Man, I'm rusty. Okay. This is what happens when you haven't streamed in like 2 weeks. Okay. If we were to take the second derivative, then this is going to become just 6x. Because I forget that this is a constant. 3c. Because I'm taking the derivative with respect to x. My bad. Okay, so for this to be equal to 0 means that x is 0. Which means that we have negative 3c is equal to 0. So this is the first derivative, because I know its gradient is going to be 0 when x is 0. So I plug that into here, and then I'll have this. So c is 0. Great. I should have known this. It was right here. You can clearly see that has a gradient of 0, but it's also an inflection point. That's fine. Okay, one local maximum point and one local minimum point. So what we have is, here's my derivative. And we need to find out when this is equal to 0. And we want to make sure that we have one local maximum point and one local minimum point. In other words, this needs to have 2 separate solutions for x. One for the maximum, one for the minimum. And we know how to do that. We're going to use the discriminant. So it's going to be b squared, which is just 0, minus 4 times a times the discriminant c, not this variable c. Oh, and this needs to be positive, not equal to 0. Sorry, you want 2 solutions. So and so what do we get? Basically, as long as c is positive. Because you're gonna have, what, 36 c? So if c is positive, we're gonna have a maximum point and a minimum point. And you can see that with the slider as well. Okay, here's 0, right? You can see it has a gradient of 0 here at the inflection point. And then as long as c is positive, we begin to have a maximum point and a minimum point. So that makes sense. Okay, and then no points where the gradient is equal to 0. In other words, we're solving for, again, this discriminant to be less than 0. We don't want it to be equal to 0 because that means it it has a critical point, which might be a maximum or a minimum, and then doing this, you get the opposite. And this kind of makes sense. And you can see it on the other, on their example right here, right? When C is negative, you do not have a maximum or a minimum because it like twists the other way. Okay, easy peasy. Now, given that the graph has one local maximum point and one local minimum point, show that the y-coordinate of the local maximum point is this. Okay. So now that we know that we have a positive C value because it says you have one maximum, one minimum, we're going to solve this equation. This is the first derivative equal to 0 because this is going to give us our critical points, which are going to end up being our maximums and minimums. So blah, 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 blah. You're going to get x. The x value is plus or minus the square root of c, or c to the power of 1/2. And it wants us to find the y-coordinate of the local maximum and the local minimum. Okay, so we're going to plug this into the original function. So plus and minus c to the power of 1/2 cubed minus 3c times plus or minus c to the 1/2 plus 2. Yeah, this is the original function. Okay. And then continue evaluating. If you cube a positive or a negative value, it will stay positive or negative. So this just becomes plus or minus c to the power of 3/2. This is a negative, so when we multiply it with this plus or minus, it's going to become minus plus. And then you have c times c to the power of 1/2, which is another 3/2 plus 2. So hopefully I did this right. Let me just double check my work. The long-awaited stream? Yeah, I know. Maybe it's because I took too long and then everyone forgot about me. And that's okay. Maybe I tried to do this too fancy. But this is definitely correct. Plus or minus the square root of c, right? Okay, that looks good. And then plug it into the function. The original function is x cubed minus 3 times c times x, which would be this x value, plus 2. Okay. And then I need to show that the maximum point will be this or this. So I guess I shouldn't plug it in like this because that's a little misleading. Let's just try both of them separately. But I feel like I'm going to run into that same issue that I had. So let's do positive c to the half. So this is my x value. and then I would plug that in. So c to the 1/2 to the power 3 minus 3c. Oh, never mind. Okay, undo. I was right. Okay. You can do it the fancy way. I was just being dumb. For some reason, I forgot there's a 3 here. Okay, so now, if we follow the plus, then the second term needs to be minus. And so what happens is you're going to have c to the power 3/2 minus 3 c's to the 3/2. So you're going to end up with negative 2c times 3/2 plus 2. If you decide to plug in the negative c to the 1/2, you're going to have negative c to the 3/2 plus 3 c to the 3/2. So then this ends up being the positive version. Okay, and then obviously the negative one will be smaller than the positive one. So of course that means that positive 2c 3/2 plus 2 is your max. Negative 2c 3/2 plus 2 is your min. Okay. Now, if c is positive, find the set of values of c so that the graph has exactly one axis intercept. Okay. And then exactly 2 axis intercepts, and then exactly 3 axis intercepts. So as you can see from this graph, when c is 1, you're going to have exactly 2 x-intercepts. If c is going to be larger than 2, you're going to have 3, 1, 2, and then 3. And then as you saw before, if c is going to be less than 2, then you're probably only going to have 1 x-intercept. And again, all of that you can kind of see in the 4 graphs that you're working with. But if you wanted to do this in a more official manner, then what do you need to do? If you have one x-axis intercept, then that means that both your maximum and your minimum value, if you imagine what they look like, essentially your minimum value needs to be positive. Because if it's negative, then that means that the graph has to dip below the x-axis, so then you're going to have x-intercepts. So if you don't want no x-intercepts, your minimum value needs to be still positive, so that again, it's going to be above the x-axis. So solving for c, what do you get? You get c to the power 3/2 needs to be less than 1. In other words, c needs to be less than 1. Oh, maybe it's not just 2 then. Maybe it's just less than 1. Let's just double check this. Oh, I was misreading this. Oh, this is when c is 1, so sorry, this shouldn't have said 2. likewise, if you want two x-intercepts, then that means that your minimum value, which they told you is this, it needs to be 0, so that your minimum value is the second x-intercept, because you know that it kind of like bounces away. So doing this, you'll get c is equal to 1, and then of course if you want 3, then you do the same exact thing. This is going to be equal, or sorry, greater than 0. So c is greater than 1. Okay, and then, oops, that's the next question. Oh, I'm not done. Oops. Okay. And then finally, we're going to put everything together and find all the conditions, including D, such that the graph has exactly one axis intercept. Explain your reasoning. Okay, so this one, if you think about what D is the y-intercept, because you would plug in 0 and you just get D. So let's think about all the different scenarios of shapes that this cubic can make. So let's deal with first the situation where D is positive. In other words, we have an x-intercept above the x-axis. So if we want exactly one axis intercept, then we've already done that. That's this situation that we've been working on this whole time. One axis intercept. Wait, what? Oh, one x-axis intercept. Oh, this one should, sorry, this one should be no axis intercepts. This one should be 1. But we already did this one. It's when C is positive. Maybe. Actually, no, it depends, because now this is D. Let me just double check and make sure that D doesn't pop up anywhere else. Blah, 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 blah. You get C's. So this one, C's 1/2. Okay. So, first off, the values if instead of having +2 we have +d, these are the values of your maximum and minimum points. Oh, jeez. Okay, hold on. One axis intercept. Okay, first off, we can have it look like this. So this means that when C was whatever it was, I should have kept track of these things. Point of inflection with a 0 gradient. So when C is 0, right? Or when C is negative. So there's that one. There's when C is equal to 0. So it'll look like this. And then when D is positive, we have to be careful about, well, actually, we don't have to be careful because we already know what the situation is. If you only want one, x-intercept, then that means that your minimum value still needs to be positive. So kind of working off of this one, except again, instead of +2, it's D. We need this. So solving for C, so as long as C is less than D over 2 to the power of 2/3, you will have this situation here. Okay, so again, this is exactly for one X-intercept. So that's 3 scenarios. And then let's consider different values of D. We considered all the positive values. Now, let's think about what happens when D is negative, or sorry, equal to 0. So if that's the case, then your graph goes right through the origin, and you can see that there's only really one way, 2 different ways to draw it so that you have one X-intercept. And it's the first 2 scenarios here. Because the moment you create a maximum and a minimum, you're going to have, what's it called? 3 X-intercepts. So you can see this on Desmos here. If I change this to 0, so here's -1, and then it keeps like rotating around the Y-intercept until it hits 0, and then as you can see, it still only has 1 X-intercept, and then at this point the gradient is 0 here. And then as we rotate past this point, you're going to have 3 X-intercepts, because that's just how it works if you look at it. So that is another 2 situations when D is 0, you can have C be negative. Or you can have it be equal to 0 as well. And then, what do we got? The last situation, which is kind of the opposite of the first situation. If your y-intercept is below the x-axis, then again you can draw it like that, or you can draw it so that you have your inflection point like that. Both of these, you have one x-intercept. And then you need to think about the other situation where you have a maximum and minimum. So this is kind of the opposite situation as this one. Instead of having the minimum be positive, we need the requirement that the maximum needs to be negative. If the maximum is positive, you're going to go over the x-axis. So you have at least 2 x-intercepts. It can't be equal to 0 either. So we need to ensure that our maximum point is negative. So in other words, this inequality, we need to make sure that, oops, not that inequality, the maximum inequality, this one, We need to make sure that this is negative, less than 0. So if we do that, we're going to have 2, well, C 3 over 2 is going to be less than negative D, which means that C is negative D less than negative D to the power 3 over 2 over 3. Okay, so if this happens, then I believe our maximum is negative, so that we have just one x-intercept. And there you go. I believe these are the 8 different ways that you can... Where's... Ay. These are all the conditions so that you have one x-axis intercept. Right? That makes sense. I'm gonna go with this. Might be wrong, but I feel like it's right. Okay, I've been streaming for almost 40 minutes. How long was this question supposed to take? 27. Oops, I took twice as long. But I made a lot of stupid mistakes. And I'm also kind of going through it slowly to try to explain it to y'all. Okay, next question. What are we exploring now? The question asks you to examine various polygons for which the area is the same as the perimeter. So, for example, a 3 by 6 rectangle has an area of 18, and it also has a perimeter of 18. Cool. So let capital A be the area, let capital P be whatever. Find the side length S, where S is obviously positive because it's a side length, of a square such that A is equal to P. Okay, well the area of a square is side times side, side squared. The perimeter of a square is 4 sides, S plus S plus S plus S. And then we need to solve this, so we have this quadratic. You can factor out the S. So you have two options. You have the trivial answer, which is if you don't have a side length, then obviously the perimeter and area are the same because they're both 0. Or you have the side length is 4. Cool. An n-sided regular polygon can be divided into n congruent isosceles triangles. Let x be the length of each of the 2 equal sides of one such isosceles triangle, and let y be the length of the third side. So y is the length of the actual side of the regular polygon. The included angle between the 2 equal sides is, well, 2 pi divided by n, because n is how many isosceles triangles you have. Cool, okay, so here's your diagram. This took up a lot of space. Write down in terms of x and n an expression for the area A of one of these isosceles triangles. So we can just use our area of a triangle formula, which is 1/2 times x squared times the sine of the cosine in between, or something like that. So x squared sine 2 pi over n. At least I think that's the formula. Let me check. Geometry. Yeah, see? Area of a triangle. Okay, I'm gonna leave it like that. It's only 1 mark. Now we need to show that y is equal to this stuff. So y is equal to that. There's lots of ways that you can show this. I guess the easiest way is to use cosine law, even though this has a sign. That's my gut instinct. Use cosine law. But obviously cosine law won't have a sign. But maybe you just need to use an identity afterwards. Sure. That's what my gut says. There's probably an easier way, but let's just do that. So using cosine law, y squared is equal to x squared plus x squared minus 2x times x, well, I'll just write it like that for now, times cosine of the angle in between. This is kind of gross. Oh, we'll keep going. So y squared is equal to 2x squared minus a 2x squared times a cosine 2 pi over n. And then that means that y squared is equal to 2x squared, bracket. I'm factoring out the 2x squared, and then I'm going to have 1 minus cosine 2 pi over n. And then how's this gonna work out? I feel like this is way too much work for 2 marks, and it's probably an easier thing that I'm not seeing. Okay, let's just keep going with this. This is technically a double angle, so this is kind of a hint. You want pi over n, and right now I have 2 pi over n. So I'm going to use a double angle. And I want sine, right? So I'm gonna use this one. 1 minus 2. Hey Tofu Char, how's it going? Okay, I think I got it. Okay, this looks nice. So 1 subtracts with 1. And then I'm gonna get, after you multiply everything out, 4x squared sine squared pi over n, and then we're done. Wow, was this just 2 marks? That's a lot of work for 2 marks. Maybe there is a more astute observation I could have made somewhere. But there you go. Well, at least I showed it. Now, consider an n-sided regular polygon such that A equals P. Use the parts B and C to show that A equals P equals 4n tan pi over n. So I'm using this thing and this thing. Okay, so A is the area of the entire polygon. So the area of one of the isosceles triangles is this thingy, and then we multiply that by all of them, so times this by n. So we're going to have n over 2 x squared sine 2 pi over n. Okay. And then this is the perimeter. Well, not the perimeter, this is the length of one of the sides. So I'm going to multiply this thing by n. So P is 2 n x sine pi over n. And then I need them to both equal 4n tan pi over n. And this is 7 marks. It's a doozy. Okay. I wonder which one's easier to work with. So this is what I'm thinking. Right now, there is no x in it. So I'm probably going to need to find an expression for x in terms of n. Substitute it in. Do an identity. But I don't see how you can relate x directly with n without including y as well. Okay, well, here's the thing. Let's reverse engineer this. P. This is y, which is this. You know that there's n of them, so we're adding that n times. So it's n times y is the perimeter. So it's going to be 2nx sine pi over n. And then we want to change that. This needs to become 4n tan pi over n. In other words, if you think about it, that means that x needs to become 2, 1 over cosine pi over n. Otherwise, you won't get 4n tan pi over n. So how can I show that this is true? That's what I'm thinking. See, this is why I didn't want to do this stupid paper. I want something easy to stream and that, you know, people don't see that I'm struggling. Well, you know what, we know that these two are equal, so let's go with that for now. Maybe we can get an expression for x. Let's see what we got. We know that a equals p, so that means that these two things are equal to each other. And then won't let me change colors. So this n is going to cancel out this n, this x is going to cancel out with one of these x's. Looking good. So now I have an equation. I can solve for x. So since a equals p, we have this. So x is equal to 4, so that's good. I got that 4 part. And then, oh, okay, yeah, I see it. Easy peasy. Isolating for x, we get this. This is a double angle. I use the double angle identity for sine. The sines cancel, and then I get exactly what I wanted to show, which is x is equal to 4 1 over cosine or secant pi over n. Good. Now that I've shown that, then if I were to plug it into p, did I do this correctly? I feel like my coefficients are off. When's that movie? Tomorrow at 8. Tomorrow at 8. We're gonna watch Weathering with You. Okay, I need 4. And I have 8. So this needs to be 2. So where did I go wrong? Oh, whoops. Forgot my 2 here. In my double angle identity. So that should be 4 divided by 2 is 2. That's 2. And then, okay, I've shown this. Easy. Am I going to play any games today? Probably not. As you can see, or maybe you can't see because it's dark. Let me turn on my light. But haven't unpacked yet. Well, I have slowly, but not too much. That's part of the reason why I haven't been streaming lately. I've been busy with the new place, been busy with work, and also I've been very tired lately. I don't know why. It's just one of those things. Okay. How long have I been living here? I don't know, like 3 weeks? It takes a long time to unpack stuff, you know? June vibes. Yeah, everyone's tired, right? It's the end of the year. And it's been a rough year. Pandemic. Okay, that was our expression for A. And then I'm gonna substitute in my expression for X. Okay. Okay, this looks pretty straightforward. 2 squared is gonna be 4, right? And then 4 is gonna divide with 2. So you can get 2n. I'm gonna have a 1 over cosine squared pi over n. And then we're gonna use the double angle identity here. And then we got some more cancellation. One of these cosines cancels out with that one. And then I'm basically done, right? 2 times 2 is 4, we have n, and then we have sine divided by cosine, which is tan. Hey, we're done. Nice. Okay, and then the final page. So Maclaurin series for tan of x is going to be this. So then we're going to use this Maclaurin series to find this limit. Okay. Okay, so 4n tan. And then this is pi over n, right? Okay. So we can do a substitution. We're going to write tan of x as this Maclaurin series, and then instead of x, we're going to write pi over n. So this is all going to become 4n times whatever the Maclaurin series is. So x, so in this case pi over n, plus x cubed divided by 3. So pi over 2 cubed divided by 3 plus pi over 2 to the power of 5 divided by 5, and so on. Wait, not pi over 2, pi over n. Okay, simplify this expression. We're going to get 4 pi plus whatever this is, pi cubed over 4 pi over 3 to the power of n squared plus 4 pi over 5 to the power of n to the power of 4, and so on. Okay. Music's chill? Yeah, it is chill. Okay, and then if we take the limit of this as n goes to infinity, anything with a denominator of n, which is basically every other term except for the first term, goes to 0, approaches 0. So we have this, 4 pi. Now, interpret this answer part geometrically. So if your sides approach infinity, then this is essentially the area slash perimeter. Well, it's not called a perimeter anymore. Hopefully you guys see where this is going. This is the area of a circle. Of a circle and perimeter of a circle. Or stop saying perimeter. Perimeter of a circle is called a circumference. So there's a circle that exists that has the same area as it does its circumference, and that value of both the area and the circumference is 4 pi. Okay, now consider a right angle triangle with side lengths A, B, and then the third side, which is just Pythagoras, sure. A is the smaller one, okay, one of them has to be smaller, or sorry, larger, and such that the area equals the perimeter. What does this have to do with what we just did? Okay, whatever. Show that little a is going to be 8 divided by b minus 4 plus 4. Fine. Okay, area is base times height divided by 2, so a times b divided by 2. Perimeter is a plus b plus a squared plus b squared. We set these equal to each other. And then what am I trying to do? What am I trying to show? Solve for a. Really don't want to solve for a. This one's also 7 marks. Before I solve for a, I'm just gonna think here for a second. Does this have anything to do with what we've done earlier? Or is this just another question? Okay, whatever. Apparently, this has nothing to do with the earlier stuff. But I might be wrong. Today really felt like Friday? That's because the last 2 weeks we've had 4-day weeks because of Prody Day and holiday. And this is our first 5-day week back. At least tomorrow's a little bit shorter. There's the walk about at 2:30. And then I think that'll take, 20 or so minutes, and then you'll be dismissed from the field outside. And it's okay. At 2:30, we're gonna do a walkabout in honor of the children at the residential school. And that starts at 2:30. And then you'll be dismissed once we're done the walkabout. I don't know how long it will take, but it might take half an hour. So dress for the weather. Why is it only in the afternoon? Don't ask me. I don't make these rules. I think it was a very last minute, organization. And it's fine. There's after tomorrow, there's only 4 more weeks until the summer. I don't know if that makes it a good thing or a bad thing for you, Vincent. Does that make you feel more pressured or make you feel relieved? Scared about English and TOK, but everything else is fine. Well, we still didn't do that podcast yet, right? Okay, I'm gonna do something. I feel like this isn't the way, but I'm gonna do it. No, I finished, so he could include it in my midterm mark. Okay, that's not bad then. I did well, I'm happy. Nice. But you almost always do well. Okay, this is my idea. And I feel like this might be the right way to go. I don't know. It's a 7-mark question. I'm going to move the A and the B over, because notice that this expression for A has no square roots. Actually, there's not even a square. So I'm thinking I need to get rid of this square root. So I'm going to square both sides. And this is going to get real ugly real soon. Because then I have to square this trinomial. Actually, I want to deal with the fractions. I'm going to multiply everything by 2, and then I'm going to have AB minus 2A minus 2B is equal to 2 root A squared plus B squared. You finished updating your photography portfolio. Do you think your teacher had enough time to mark it for midterms? I don't know. The marks were due on Wednesday. But everyone was scrambling to do it. Until the end of this week. I know I was too. Okay. Is this factorable? I don't think so, right? Or else you get a C? It's fine, it's just a midterm mark. Who cares? Tokufuchar, he's a year younger than you. It's totally not factorable, right? There's no way that this is factorable. It's not factorable. You have to have 2A, and then you have to have a 2B in there. How are you going to get -1? I just don't... I'm trying to avoid cubing a trinomial, because that looks... Or squaring a trinomial. But I might just have to. Okay, I'm gonna just do a quick little cheats here. Wolfram, please. Can I factor this? Just tell me. Fairly sure I can't. I'm going crazy. Yeah, not possible. Fine. Then I'm gonna ask you for a favor. Another one. Expand this for me. Square it for me, please. Jesus. Okay. I don't know if this is the right way to go. This looks like it's getting worse and worse. Square both sides. So on one side, I'm gonna have 4 times a squared plus b squared. There's no answer key. This exam was just, you know, a month ago. Okay, I have some hope though. Because notice there's gonna be some cancellation. Goodbye. 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 Okay, so what do we got? We have a squared b squared minus 4a squared b minus 4ab squared minus 8ab needs to equal to 0. These all have a common factor of a and b. So ab, so this becomes ab minus 4a minus 4b plus 8. I think we're here. Okay, so if this needs to equal to 0, so that means that this factor needs to equal to 0. ab minus 4a minus 4b plus 8 needs to equal to 0. Okay, that's cool. And then I'm solving for a, right? Yeah, I'm solving for a. So we're done. Okay. I got a. I'm going to factor it out of the first 2 terms, so I have b minus 4. I'm going to move the other 2 terms over, so I have 4b minus 8. So then a is equal to 4b minus 8 over b minus 4. And then so they really did want me to expand a trinomial. Whatever, it's HL. Okay, and then I can factor out a 4. So I get b minus 2. Wait, no, I split it up, right? Hold on, what am I trying to do here? What am I trying to make it look like? Not quite done. Almost there. This thing. Eight plus 4. 8 plus 4. How do I get 8 plus 4 from this? Okay, well, we're just gonna have to finagle some things because we know what it should look like. What it should look like. Okay, first off, I'm gonna write that 8, that minus 8 as a... What am I gonna write it as? I'm gonna write it as a minus 16 plus 8 instead. And I'll show you why. First off, there are no variables of b in the numerator. So I'm thinking I'm gonna split up this fraction into two pieces, and one part of the fraction is gonna cancel out the b's. Actually, the b minus 4. So hopefully you can see that. Now if I factor this out, I'm gonna have b minus 4 over b minus 4. And then I have plus 8 over b minus 4, and then I'm done. Mission accomplished. Suck it, HL. Okay. Okay, by using f, determine the 3 side lengths of the only 2 right-angled triangles for which A, B, A, P are integers. So we want integers. Determine the 3 side lengths so that they're integers. Okay. Well, first off, if we want A to be an integer, then b minus 4 needs to divide 8. So what are your choices then? Remember, A and B are side lengths, so they have to be positive. So the first choice is if you have 8 divided by 1. If that's the case, then that means that B needs to be 5. If B is 5, then B minus 4 is 1. Then 8 divided by 1 is 8, plus 4 is 12. And then that means that my perimeter might be an integer. We need to double check and make sure that this is a Pythagorean triple, but I think it is, right? 25 plus 144. This is 169. And then 169 is 13, right? Okay, so this works. And then I'm just gonna try the next one, which is 8 divided by 2. So then if it's 2, then that means that B needs to be 6. Which means that A is going to be, well, if B is 6 and this is 2, then 8 divided by 2 is 4, and then 4 plus 4 is 8. So 6 and 8. And then let me just double check. And the third side, 36 plus 64. Well, that's 100, right? Okay, nice. There you go. Found my 2 triangles. And then find the area and perimeter of these 2 right triangle, blah blah blah. Okay, fine. You really want to do this? Okay, triangle 1. I'm gonna call this one triangle 1. So area. Actually, screw the area. It's easier to find the perimeter, and I know that the perimeter and the area are the same. So 5 plus 12 plus 13. A equals P, which is 5 plus 12 plus 13. What the hell is this? 30, right? And then A equals P, number 2. 6 plus 8 plus 10. So 24. And then I'm done. I think that was the last bit, right? Let me double check. So you know that dude that I sent the paper 1, 2, and 3 to? He still, I think it ghosted me. Whoever you are, I forget your name, Lawrence or something. Hold on, let me go to my email. Lewis Verstappen, if you're out there, I hope you feel good about yourself. Abusing my goodwill and my trust, and ghosting me. And I hope you're happy with your TZ1 papers. Does your 80-year-old math teacher even exist? Is this all just a lie? That's so sad. This always happens. This is why I'm cynical. I used to be so innocent, so optimistic as a first-year teacher, so trusting. Not that I'm not trusting now, but you know, jaded. Because after years and years of, you know, students coming to abuse your trust, it just wears on you. Like, oh, I'm sorry, I couldn't come to school today, and I missed the quiz, my grandma died. And it's like, oh no, are you okay? And then you find out their grandma is still alive. And they were actually just in the tennis court, hanging out with their friends or something. Who knows? No, that didn't actually happen, but has that happened to you? Not the grandma excuse, but you know, you can tell when a kid's lying when you ask them, like, where were you on this important date, aka quiz or test date, and they always have some sort of excuse. And then you ask, you know, other teachers, you ask the counselors, because obviously they give you a serious excuse, and they go, no, they're lying, because obviously they are. And it's like, they know me too, and it's just, if you just talk to me and say that you weren't ready, then I would have been like, okay, just come do it another time. But I get that, you know, that might be difficult for some students to say that. Point is, once again, I've put myself out there. I trusted someone that I shouldn't, and then I got hurt. And so I now, again on that scale, for my students that know me, and I talk about if I make a bunch of money, right? There's a scale, and it goes back and forth. Do I stay for 3 years, 1 more year, and then I see off, you know, my senior students that I've been teaching? Or if I have that much money, do I just peace out? And each time this happens, I move more towards piecing out. And then obviously, you know, if good things happen with students, then I lean towards the other side. For example, the other day, our student council president gave me a bunch of dumplings that his mom made. So that means that I went over to this side. Yeah, well, it's nice. Lots of students are nice. I'm not gonna say that they're not nice. You know, it's COVID, so none of the alumni are allowed back, but they always come back and visit me and give me food. And you know, just people coming into my room and saying hi is always nice. But point is, I got played. Ugh, I don't even want to think about organizing elections. Why don't we just chill for like 4 minutes? And then that'll round me up to an hour and a half. How much time do you have on this paper? 28 plus 27, and then I'm sure there's a little bit of time. Have you placed your bets? Like money? I don't know, it's tough. I don't even know who's running for what, aside from the presidential candidates. And that's a tough call, because like, they both have their own friend groups. And they're both like fairly involved with the school, right? I honestly don't know. Yeah, I have predictions, at least for the president. But we'll see. Are you running for anything, Vincent? VP? Yeah, well, it's between two people. There has to be one that's better. Secretary? Why don't you run for VP? Who's running for VP? Because that's gross. Yeah, it's okay. You're already involved too much in the school. You're gonna get lots of money next year. Make sure you apply to lots of scholarships. The Loran, the VZ, the Schulich, everything. Anything that's big. I'm sure you'll get one of them. BD as well. I guarantee you, you're gonna get one of those things. What who do? Don't use pronouns when we don't know exactly who the subject is. The president? The president didn't do anything. We're talking about next year's president, because the elections are gonna happen. Oh, what did he do? He gave me dumplings. Because, okay. Mainstream kids, of course they do. Like, the main thing to get scholarships is that there's three qualities. You need to be good at school, or you're involved with the school. Okay, let's say four things. Or you're in financial need, and then this one is kind of like a distant fourth, is you do a lot of, you do sports. But if you tick, any of those four, you will get money. And the more you tick off, the more money you get. But sports is like a distant fourth. It comes down to those three. Oh, and then, okay, actually, that's a distant fifth. Let's say fourth is you're a good person, because the teachers are the ones that decide the scholarships from the school. The ones that you apply externally, which are actually the larger ones, your teachers will write you references if you ask them for it, but those committees decide. Like today we had our first scholarship meeting for this year's grads, and we're just talking, like, oh, what about this person? What about that person? What about this person? Oh, wait, this person's all talk. We shouldn't give them this award that's about service, because, they always sign up for things and then they never follow through. And it's like, okay, never mind, take them off the list. What percent of students get a scholarship? It's kind of sad, but there's a running joke that if you don't get a scholarship at our school, that means that like you basically barely existed. We have so much money and scholarships that we literally have to stretch and try to make people fit into the categories so that we can give them money. That's how much money we have. It's like, okay, we have this little scholarship, is there anyone that still needs money? The scholarship's about like, being Asian, like heritage. And then it's like, okay, well, this person didn't get a scholarship. Can we consider them Asian? And then it's like, like I'm exaggerating, but it like the meetings are like that sometimes. It's like, Russia's beside Asia, maybe. And then, okay, whatever, put them in. Again, that's not a real conversation, but like we've had to stretch to make people win a scholarship because we just have so much available. I think this year we have $500,000 of scholarships. That's a lot of money. But yeah, exciting. So Vincent, I think you'll have lots of money, which is good. Lots of service, good person, financial need, great grades. Yeah. Definitely talk to, people in the school that know more about scholarships, like your counselor, although it'll be a new counselor, I guess, next year. But maybe talk to the homework club counselor. She knows quite a bit, and she's willing to help you guys out. Because, she's lots of your grade go to homework club. You can ask, Big Mama M, our community service, our community outreach worker. She is very knowledgeable. I would honestly go to her first for external scholarships. Our community outreach. Big Mama M. Yeah, Big Mama M. Because she was actually advising our student council president whether or not he should accept his scholarship. So his scholarship is a lot of money. It's like $100,000, except it's quite limited. You have to go to specific schools. They don't pay for your residence, etc., etc. So it actually might not be worth it. Jazz, right? She won that scholarship and she had to give it up because she wanted to go to, UBC, and her scholarship doesn't apply to UBC. So, yeah, Big Mama M's kind of knowledgeable about that kind of thing. But yeah, again, our homework club counselor is also very knowledgeable because, she's helping out the current grads because those are her grade. So you're in good hands, but you should definitely apply. You think she's scary? There's no way. Yeah, don't talk to me though. I can be your reference, but I don't know if you want me as a reference. I'm not saying that I can't write well, but obviously, I'm a math teacher. But, you gotta pick. You gotta write to the scholarship. If the scholarship's about marks and math and science and stuff, then sure. But obviously if it's about community service, maybe talk to a teacher that knows how much community service you have done, like the librarian. I'm sure she'd be very happy to write you a reference letter, and I'm sure she writes an excellent one. You know what the awkward one is? The awkward situation? When there's a kid who asks you to write them a reference letter and you don't even know them that well. It's like, why are you coming to me? What do I have to say about you? And that's happened sometimes. And it's a struggle. I don't know what to say. Auto-generate. I don't know. Sometimes people just, they're like, can you write my reference letter for me? And then I go, sure. And then I'm just like, tell me what you want me to say. And then they'll just send me a list. Like, include this, say this, make sure that they know that I do this. And honestly, that's pretty useful. And you should be doing that for any reference letter anyways, for any teacher that's going to write your reference letter. And you can apply to schools next year. and then you gotta pay for your applications. But with your average, I think you'll be fine, Vincent. No idea? Don't go into teaching. Don't get a math degree. It's fine if you don't know what you're doing. Teaching would be cool. Being an elementary school teacher or a high school teacher? High school for sure. And what would you teach? Would you be an art teacher? History teacher? 2.0? 2.0 implies that you're an improvement over the current history teacher. Although, to be fair, you are. She told me lots of times that you write better than she ever could. At least her when she was in high school. And sometimes in university as well. Not in English? That's fine. I mean, if you enjoyed history that much, then sure. You can be like why not do like some historian thingy-mabob? Be an archaeologist. Or be a librarian. You know you need masters to be a good librarian? Not like a high school librarian. But like, I just mean like a librarian in general. Especially at like a university level, you need to be very qualified. I don't know. Like, have I ever... I know I've talked to the student council president about, you know, the upsides and downsides of being a high school teacher or a teacher in general. I'm fairly sure you know as well. It's a lot of work. A lot of work. Not a lot of pay. It is rewarding. But you gotta think, is it worth all that work and all that not money? Because if it's not, then don't do it. And then the important thing is, are you willing to put yourself out there, you know, do everything you can for the kids and have them, you know, you will never have it reciprocated back to you 100% at least. So that's something that my sponsor teacher said when I was a student teacher. You can put 100% of yourself out there, and you know, they're high school kids. Hello, Mr. Goldiflox. They're high school kids. They don't have that emotional capacity to realize how much work you do for them, and so you will be exhausted at the end of every year. And I'm not saying it's a bad thing, but that's just the reality of things, is like, you will never be fully appreciated for all that you do. And there's no way that you can, because they have no idea behind the scenes, because they're kids. So give it some thought. You might become even more jaded and bitter than you already are, Vincent. Is that even possible? I don't know. I don't know if it is. What are y'all talking about? Maybe I'm just confusing you being stressed. As kids grow older, they recognize your sacrifices, Well, yeah, they visit later when they're older and they're like, wow, I didn't realize you did so much. Or they go into Reddit and then they go into some stupid post that's like, what amazing teacher did you have in high school? That shit don't matter to me, okay? Because you're already out of my class. You've already had your time with me. Unless, of course, you made money. And then you give it back to me. Or you come and visit and buy me food. But like, you already gave me the hard time when you were a teenager. And yeah, I always enjoy seeing students as adults come back, because you know they change. But you know, your time with me's past, right? If you're a little shit back then, just because you're a better person now doesn't mean that that erases all the times I had to deal with you. But that's just life. I guess this is just free life advice, right? There is no way you will ever be reciprocated 100%. And I think you need to not have the expectation of anyone. It's just, of course, you, instead of like normal people with your friends and family, you have, you know, 100-something students that don't reciprocate. So it's a little bit rougher for teachers sometimes. Okay, for real. But people who give you a hard time but then realize it and change you should be happy. I'm not saying that I'm not happy. I'm just saying that it's been done. The moment has passed. You've already taken my trust. You've taken my goodwill. And you've ruined it. And you did not pay it back until, who knows, years later, when you're an adult and you're more mature. You appreciate me? Thank you, son. There's so much hope in education. Of course there's hope in education. Literally making the future. You know what our job website is called for when you look for like postings? It's called makeafuture.com. Yeah. Like I said, I wouldn't be a teacher if I didn't enjoy it. I'm just telling you that this is the truth. Why do you think teachers are so exhausted by the end of the year? Because, well, at least, like, you know, the ones that care. Because they've been caring the whole damn year, and there's very few kids that care back. You wonder how long I'll be teaching? Until I frigging retire or I make a bunch of money. What else am I gonna do? I enjoy teaching. You can treat me to non-alcoholic beer. Just buy me food. Some people just ditch and pursue something new. Yeah, that's true. I mean, there's lots of people that, you know, when they're 30-something, 40-something, even 50-something, they change career paths. So, I don't know. I'm not going to say never, but I came into this, like, for the long term. And, you know, it hasn't been that long yet, you know, obviously compared to other teachers. It's been like 5 years, but I'm not tired of it, and I'm not regretting my choices. And I can see myself doing it for, I don't know if, I'm not saying that I can't see myself doing it for the rest of my life, but I'm not going to say that I'm going to do it for the rest of my life, because I don't know what's going to happen. I mean, I'd be happy to. Oh yeah, our student council president asked something. He said, if you could go back and then do everything all over again, would you still become a teacher? And then I told him no. And the reason is not because I regret choosing teaching, but if I have this second chance, I'm gonna try something new and then see what I missed. If I had to go back in time and I couldn't change anything and I just had to re-experience everything from scratch again, yeah, I don't care. I'm happy with my choices. How long do you see yourself staying at your current school? Would I have still stolen a Lunchable? 100%. I just wouldn't have gotten caught. I don't know how long I'll stay at this current school. I really like it. And I wouldn't have stayed this long so far if I didn't. Does teaching not get stale? No. Even if you teach the same thing every year, okay, this is a little hard to explain. Because you guys, unless you've had me literally every year, you don't know that every year I change my teaching practice. So that's why I'm always so busy, even though it's my 5th year teaching something. Like every year I make quizzes from scratch. I might copy and paste and borrow a couple of questions here and there, but I changed the way I mark quizzes. I changed the way I teach classes. I changed the way I grade everything, how I structure quizzes, whatever, how I teach. Some of you guys know this with what I'm trying to do right now with my grade 8s. So it's not stale because I'm always trying something new. And not only that, but every year I have new students. So even if I'm teaching the same course in the exact same way, I have new students, and that keeps it fresh enough. So it's not that stale. I think it only gets stale if like you let it get stale. If you become that teacher that just has like a binder full of old tests, and then you have your lessons already planned out and you just repeat it and regurgitate it over and over again, then it might get boring. But as you can see, I don't do that because, I don't know, I just hate myself, I guess. But yeah, as I am right now, I'm 100% happy. And yeah, I joke about having money, but you know. Who doesn't want more money? That was your high school teacher? Taught for 20 years? I just don't want to be like that. Where you think that your teaching practices are still relevant 20 years later? Oh, are you talking about he's like me? Where like he's always changing things? Or that he's taught for 20 years and then he's gotten lazy and just like pulls out like, you know, a test from 5 years ago? No, what? Literally binder the same things. Yeah. Like, I have a friend. He teaches physics at a different school in the city. And he's taught for the same time as me, more or less. And so he's kind of in that same situation. Like, literally one night, we were hanging out, and within like an hour, he literally planned out the whole year. He was like, on this day, I teach this lesson. On that day, I have this quiz. I'm going to finish the chapter by this month. And then we'll have the final exam at this date. And then I was like, that's crazy. I don't even know what I'm going to teach on the day of sometimes. I just walk in and then we YOLO it. Of course, to be fair, I work at a small school. So, and he works at a large school. So as teachers, a full-time load, at least for my city, is you teach 7 classes, 7 blocks. And he's a great teacher, don't get me wrong, but he can do that because of his schedule. He literally teaches only Physics 11 and physics 12. He only has to take care of planning 2 courses. You can only do that at a large school. I work at a very small school, and every year I teach 6 to 7 different courses. Every block is a different course. I don't have time to plan that out. I just walk in, and then I just YOLO it the day of. I get lots of free time. I do lots of things. Yeah. Well, profs are different. Profs, a lot of university professors are only teaching because they have to. It's part of their contract. Their main work is research. And then the university's like, hey, we're not going to pay for your research unless you teach some first years some courses. So most of them don't really care about teaching. And that's why you have TAs to grade and stuff like that. Wait, Vincent, are you still at school? Why do you two both know which spider you're talking about? Yeah, but that's life. And right now, I don't know. Going back to that, like where I am, I'm kind of in the middle. I'm kind of in the middle right now. If I make a bunch of money, I don't know which way I'm gonna go. Am I gonna stay so that I can see my grade 11s graduate next year? And then will I stay longer so I can see my grade 10s graduate in 2 years? Or, you know, if I never have to work again, do I just peace out? COVID is basically almost over. I'm vaccinated, I don't care. Just wait till I get the second one. Doesn't the thought of not existing seem so scary? No, it doesn't. If it ends, it ends. That's life. I mean, it's sad, I guess, for other people, because I'm gonna be dead. I don't get to feel emotion. Like, at least I can rest in peace. If I don't get rich and then I die, then that just means I got freed from the mortal cycle, or the mortal toil of life, of being poor. Yeah, so whatever. Look, I got life insurance. My family and partner will get lots of money. You know, the school's not gonna care. There's gonna be some students that are sad for a bit, and then in a week they're gonna hire someone new. I'm not that important. Yeah, who cares? I'm gone. Hard to wrap your head around it. No, I'm an icon. Look, this is why, you know, you live a life that you're proud of and that you're happy of, so that, you know, it's hard to say because you're gonna be dead, but at least when you die, if you have the time to think and reminisce before you die, you can die with very little regrets. It was Ivana Slay. Man, grade 8 was wild. I don't know, Goldilocks. You're asking the wrong person about what they think about death. Because I'm very... Like, obviously I would like to live and as much as possible so that I maximize my enjoyment of life. And I'll do everything I can so that I extend it. But if it happens, it happens. And what can I do? I'm gonna be dead. I mean, if you're so scared of death, then just don't ever leave your house. Spiders in the washroom? Okay. No script, Leo. I'm gonna end the stream soon. Finally someone understands what? The spider? So there's a grade 12 student that was talking about how she found this massive, thick spider in her washroom. And then she said, okay, I put a jar over it. I was like, great. And then you like, you know, put a piece of paper under it and then you like released it outside, right? And then she said, no. Now there's just a jar on my floor in my washroom and it's been like that for 2 days. Everyone's scared to move it. And she's like, I'm surprised it hasn't died yet. just get like a piece of cardboard, slide it underneath, bring it outside, open the jar, shake it out, and then it'll probably run away. And then there. Don't kill it. Don't kill it. Oh man, and then I went to this outdoor store over the weekend, and then they had those shotguns that you like load up with salt, and then you like shoot bugs with it to kill them. Crazy. I think it's called like a salt blaster or something. But then you have like salt all over your house. But yeah, like you literally just like shoot flies with salt and kill them. Kind of want to try it. Spiders, I don't like killing, but flies, screw them. They're dying. Seems fun. Like silverfish, you're dead. Immediately. If I see you, you are dead. But a spider, you know, spiders, they contribute to the ecosystem. They eat the smaller pests in your house. I'll catch it and release it if I can. But I haven't seen this spider. I don't know what spider you're talking about. You have a wolf spider in your house? You gotta throw away the whole house. You gotta burn it all down. Move. You can't let it multiply. You gotta end the bloodline here. Yeah, you have to burn down everything. Just burn it all down. Your mom killed it? Well, there's gonna be more. No, I'm not gonna show a picture. You Google it yourself. Go Google wolf spider. I don't want to see a spider. Just because I tolerate them and I set them free does not mean I want to look at them. You go Google it yourself. Look, you probably have some sort of wolf spider nest in your house somewhere. And, you know, they probably take some time to grow, and then after, you know, that time in the year, they venture out. I needed your... I don't know what you're trying to say. Point is, it's been 2 hours. We talked for half an hour about lots of things. But I'm gonna end the stream. Good luck with your spider problem. Oh yeah, that video where like there's a broom and it hits a spider, and then all of a sudden a bunch of baby spiders like spread out. Disgusting. Disgusting. Okay. We'll leave on that note. I don't know what I'm gonna do on Sunday, but I'll probably stream something. Goodbye. Last question, what do you want? Oh yeah, I can do a review. I'll post up the Revision Village distribution and then I'll go over it. Oh, Tofu, thanks for the subscription. When's the test? I don't know. Next week. Wait, no. Hold on. Revision Village next Sunday. I need to figure out something for this Sunday though. Maybe I'll just go over the Crystals packages. Yeah, that sounds good. Yeah. Okay, Goldiflex, where's your question? You're taking too long. I'll give you 10 seconds. Starting now. Okay, you forgot your question? Too bad. We're out of here. See you all later. Goodbye.